So I first met David Coleman at a CWNP event. So way back when, courtesy of Devin Aiken somewhere, we used to get together and try to write the CWNP test. You know, there used to be a CWNP test, and we really didn't want people to get CWNPs. It was really tough. But Coleman, I sat across from Coleman, didn't know him from anybody. I was like, man, this guy looks just like this guy. And for those of you that don't know, this is Stephen King. And I was like, the only differences between Stephen King and Coleman is Coleman's books are way scarier than Stephen King's, for those of you that have done that. Well, good morning, everyone. My name is G.T. Hill. I very much appreciate you taking the time to sit here and listen. For those of you that talk about your own product when you're up here, it's a little weak because I'm going to talk about 7 products that I'm going to shill for today. I want you guys to up your game, have more products you're going to talk about. So, the wireless journey of the humble tomato. What does a tomato go through from the time it is being picked to the time it's delivered to your door? What wireless technologies does it encounter? It's a lot. It's a really big number. I do want to give props to Mark Edwards for helping me out with this. He gave a lot of advice into what to do. But we're going to start in the field. So this that you see on the screen, there's a human in there, that's going to change. That's going to be automated. And a good technology, a consideration for a technology to do that is private cellular. My goal of this presentation is to kind of give a high-level view of a lot of different technologies. Some of you are probably newer to wireless, so this will be a primer in a few of those technologies. And the first is private cellular. You'll hear it be called CBRS, private LTE, private 5G, but effectively it's licensed wireless LAN. The wireless LAN we're used to today is unlicensed, gives us a lot of freedom. For those of you that have been doing this long enough, you know that it also gives us a lot of pain. So private cellular is an interesting option. The upsides of private cellular are really good range. So the technical side of that is really high signal and really low noise. So that signal to noise, if you are in private cellular and you're like, oh, I've got negative 110 dBm of signal, that's okay. In Wi-Fi, you waved bye-bye a long time ago to any sort of connectivity. So private cellular has some advantages there. So good range, great roaming. It actually roams. When you're driving down the road on the phone, you don't hear any bleeps or anything that are happening to your connection. That's because private cellular is really good at roaming. It's just built into the protocol. Wi-Fi is going to change that. I think Wi-Fi 8 is having some provisions to improve that. The other thing is quality of service. QoS in private cellular is really good. But there's downsides. Lower client capabilities or lower availability for clients. If you decide that, hey, private cellular is interesting, I want to use it, you have to think about clients and their capabilities. You don't do that so much for Wi-Fi. Right, we're going to install Wi-Fi over here. You don't think, oh, does everyone have a Wi-Fi device? You don't worry about that as much. There's a lot less frequency allocation. So what that means is lower data movement. I don't say throughput because throughput, we kind of think of that as, I'm going to go see how fast my connection is. Private cellular can do really well. But total data movement, because Wi-Fi has so much spectrum, is a lot better with Wi-Fi. But there's very specific use cases where private cellular is an interesting thing to look at. So what's changed? I got to give mad props to Cellular. So I don't know how long they've been coming WLPC. They're sort of what I consider to be the private cellular pioneers that entered the wireless LAN market. So props to them for doing that. Keith, how long have they been here? 7 years, somewhere in there? But a lot's changed even since they started entering that market. There's a lot more players out there. This case study is from a company called Ramen. So that's just one of the many out. Highway 9, Nile, I think, is doing some. But this case study is them using this in tomato plants, and I thought that was kind of an interesting way to start this. It's a lot less expensive than it used to be. I've seen companies get quotes in the tens of millions of dollars for private cellular, not from Solona, but from the Ericssons and Nokias of the world. But that cost has come down significantly, where it's like, oh, it's actually affordable. And the other thing for many organizations is the fear of a whole new technology. Show of hands, how many people has ever studied even a little bit cellular technology? It is daunting. Do you agree? It is daunting. There's all these ANs, RANs, and WANs, and all this other stuff, and I don't understand it, and I've purposely tried not to. But now you have companies, a lot of the models today are network as a service. The ability to, hey, put the base stations in the right place, we'll manage it for you so you don't have to deal with all of this added technology that, at least from the outside looking in, it makes Wi-Fi feel a lot simpler to me. That may not be true, but that's the way it feels. So we've, okay, the name of my computer is in use. GT's laptop, who the hell is spoofing me? Okay. So now we've got the tomatoes out of the field, they're in the packing area, and we've got them all crated up. Now we're going to track them. Something called Ambient IoT telemetry. So these are tags. I have one in my pocket. It does zero good for me to show it to you because it's tiny. But these little tags, ambient means that they get their power from the air. Now I want to contrast that to RFID. Some of you in here have used RFID, you know it. RFID is also gets its power from the air, but through choke points. So there's kind of like you ever walk through a store and it beeps because you're a thief or something like that. So these things that come through will power that tag. These tags are powered from ambient RF in the air. So 2.4 gigahertz is a great example. It's getting powered remotely. So that's how it gets its power. The company that I first encountered that is doing this is called Williot. They sent me a kit. I do recommend if you want to play with it. I think it costs a little bit of money, but you can get a kit where you can try this at home. It's a really fun lab experiment. But the first step in making these tags work is RF collection, so power collection. The tag basically takes any signal it can, stores it in power. So it just takes it in. Again, I'm using 2.4 gigahertz as the most common example. So it brings in that power. And then the next one is to harness that energy into a capacitor. A capacitor, think of it as just like a momentary battery. So it pulls in signal or energy, and when it has enough, it releases it very quickly. So that is very fast. You don't have an onboard battery per se. So that data collection, so what is the tag actually doing? The tag can do, the simple one in a kit that you would get from them is temperature. So I think when I did it, they said, put the tag on the side of a coffee cup, fill up the coffee cup, and you can watch it. But here's the interesting part. The tag doesn't have a temperature sensor. The tag actually doesn't even have a radio crystal on it. It doesn't have like a normal transmitter in the sense that we're used to thinking about transmitters. But it can do motion. I can't speak for Williot. I know that the industry, they're talking about motion, proximity, weight, and even I've heard rumors of ethylene off-gassing. Are our tomatoes ripe? We can know that in transit. That'd be really cool. But what's interesting about this technology is that it doesn't, as I mentioned, it doesn't have a transmitter. It doesn't transmit your coffee cup is 73 degrees. It doesn't transmit that. It transmits raw data that is manipulated by the environment to the tag. So this tag right now, if it was powered and it was transmitting, it would actually know this information about itself, but the physical tag changes based on the environment. I know that sounds really odd, and I'm probably not doing a good job of explaining it, but instead of it transmitting temperature or proximity, it doesn't have a location detector on it, the tag itself changes, which means when it transmits its raw bits and bytes, that is affected by the environment. So this is one of the cases where cloud is really awesome because it actually has to process that in a very proprietary way. It processes that, and this is where the smart people at Williot have done this. It processes it, converts it into usable data, and sends it to their customer. But I think it's a really fun technology. So that's where that tag is going to get applied at the location before it gets sent off. So before we transport it, though, another wireless technology that's very common today is satellite. In fact, I have satellite in my truck now because I need data. I live in Arkansas, so hopefully I don't sound like I'm from there, but there's a lot of data places I need data that I can't get it even with cellular. So the truck is going to have onboard services. Maybe it's IoT, it's Bluetooth, it may be HaLow, Wi-Fi, of course. So we need that backhaul connectivity, and satellite is a common answer for that. But I did a little, 2 seconds on Starlink and what it does. 12 to 40 gigahertz for the up and down link. It's something like over 40 gigahertz for satellite to satellite communication. It's low Earth orbit, which means you get really low latency. So works really well. When I wanted to find an image of a Starlink on a semi-truck, it's very appropriate, I think, for the presentation here. So and it appears like a lot of presenters, we're just defaulting to using AI to build our presentations today. So I did the same thing, and this is what I got. And I think it's okay. I don't. I said Starlink antenna on semi-truck, so this is it. So now our tomato has left the tomato field, hit a couple bridges on the way, but it left on the tomato field, and it ends up at our retailer's distribution center. Truck backs up, it's going to unload. Now there's a lot that happens at a distribution center. For those of you who've ever been in a retailer's distribution center, they're measured in millions of square feet. So, but one particular topic that is kind of interesting is that of robotics. So robots inside of a retailer are commonplace, but they have their own challenges. Anybody work for a robot company in here? Oh, okay. I can't talk to you during the presentation, but I appreciate that. So one of the things that Robot Co., whoever has these robots, they're concerned, just like any of you that work for a client device vendor, your concern is, can I trust the wireless network that my really expensive devices are connected to? So there's this trust issue between the retailers or the manufacturers and the robots. So what has started happening is they have decided to just give them their own network. It's like the Robot Co's are saying, let us build our own network. And I actually worked on one of these 7, 8 years ago, drove up to Wisconsin and built a temporary network for robots. They're a little bit different than these. They actually would go under like little crates, lift them up, zoom them around. So roaming was terrible. There was all kinds of bad stuff happening. But they wanted to build their own network. So that's pretty common. But now your challenges are things like frequency allocation. If I'm the retailer and they're going to use Wi-Fi or private cellular as 2 primary examples, I need to allocate them some frequencies to use that I'm not going to interfere with. So there's a lot of coordination that happens to make that occur. So from the retailer, we're going to head over to Phoenix. So our tomatoes on the way, hopefully. I placed the order last night, so we'll see. Backing up to the store. So how do we buy our tomato? Generally, we have 3 options of buying our tomato. We can have it delivered to our house, we can go in the store and shop, or we can do online pickup where we drive to the store and they bring it to our car. We're going to start with the last one. So one of the interesting things that has happened is the wireless network in a retailer has traditionally been in the 4 walls. Now they need coverage beyond the walls. Now there's many ways to do that. But the services in a store environment have extended. We're talking maybe 800 to 1,000 feet beyond the store. Now, many of you in here would be like, oh, I know how to fix that, and you're right. Let's do some mesh. We've got we've got light poles in this parking lot. They ostensibly have electricity. Let's just put some APs on there. It's much more difficult than that. The power on a lot of light poles is like 277 volt, could be 3-phase electricity. So I actually built a prototype solar panel system to go on a pole because it's really expensive to rectify that AC power down to 12 or 48 volts DC. There's a cost to that. There's a cost to a scissor lift going up, installing all of them. So I built this little solar array, batteries, and it's great. The problem is wind load on the pole. Poles are old. They may not be able to handle the extra weight. So it's very difficult to scale something like that. So I look at that problem and I say, we need to do the best we can to try to cover from the store itself. To do that, you may say, I'm going to use a big antenna. It's not a bad idea. So this antenna is, again, a little antenna primer for those of you newer. Antenna is physically connected to your access point. Its gain is limited. The total power output, called EIRP, is limited by your regulatory body. But it provides really good signal. What happens, I have to say this rhetorically, what happens when you add gain to an antenna is its coverage area is reduced. So the higher the gain, it's focusing the energy, not adding energy. So it's doing this to make your voice project farther one direction, but less others. So the signal is going farther one way, where you may want, I need 120 degrees of coverage. With your directional antenna, like this one I have in the picture, it may be 8 degrees of coverage. Maybe I'm covering like this. That's not going to cover our parking lot. So there's a product I came across last year here at WLPC. Met one of the co-founders and one of the SEs. And it's a really interesting product. And if it's interesting from like just a pure geeky perspective, it's a company called Lattice. That's how you pronounce it. And it is a wireless antenna. Now, if you're not paying attention, which I get, I understand, but you got to listen to this thing because it's interesting to think about. This is one of them. It is an antenna that provides gain. It has power, but it does not have a physical connection to the access point. There's no leads on here. I was talking in the back earlier. They're like, where's all the leads? There aren't any. It is a wireless antenna. So if signal comes in here, AP, let's say the AP is here, signal comes in here, it leaves here. It doesn't do any data processing. This is not mesh, it's not layer 2, it's not a repeater from the sense that we're used to in the Wi-Fi world. It doesn't do any of that. It is just truly it's a PHY repeater. One of the things I initially called it was an air-to-air MIMO relay. It'll have multiple chains. So if you're running 2x2 or 4x4, this thing is not smart. Does not have a processor in it. It actually just takes whatever it hears, whether it's Wi-Fi or private cellular, 5G, doesn't matter. Whatever comes in, comes out with about a 10 decibel boost. That's 10 times the power leaving this. So let's give a quick example of what that looks like. Let's take your favorite AP manufacturer. Let's say it's transmitting 30 dBm of EIRP. You do a little bit of RF math and you say, okay, at 350 meters away, by the way, this is theoretical RF math. I mean, it's real, but may not get this in real life. That you'll get neg 68 dBm at the other end. That's okay signal. And that's how it would work, right? That's your limitations. If we put this device in place, like I said, about a meter from the transmitter, we are adding 10 dB to our link. But here's the cool part. You're adding 10 dB to the link without breaking the FCC rules. Why? Because from the first meter, you lose about 7 dB at 5.5 gigahertz. 47 dB, sorry, at 5.5 gigahertz. So you've lost all of that early on. Then we're going to add back 10 dB of boost. So have I ever broken our 30 or 36 dBm EIRP? I haven't. I've added more signal to my link without compromising legality. All my radio chains are working. It's really interesting. And if you do the RF math, now you're at 1,100 meters for the same exact signal strength. I think it's pretty interesting. Just from a geek perspective, I thought it was pretty awesome tech. So now we're in the store, right? We've extended our parking lot coverage. For anybody who wants to drive up and do online pickup, you can do that. But now in the store, what wireless technologies are we working with? We're either building this for you as the consumer or the Instacart people who are walking through. We're getting them some sort of wireless services. It is going to be typical, if not already, to have tens of thousands of devices that are wireless in a retailer. That's being done today. You may have 10,000 wireless devices to do that. Can Wi-Fi do that? Just yes or no? The answer is no. Those of you wondering. Oh, some of you are like, well, if you look at the data sheets, yeah, okay. You can't do Wi-Fi. Just isn't designed for that, and that's okay. That's not a knock on Wi-Fi. It does great, but there are other wireless services that we have to start talking about. So what wireless technologies can support 10,000+ connections? Some of those connections look like ESL, DSL, electronic or digital shelf labels. You'll hear it different ways. So you just look at this right here on one single shelf. I'm not promoting Mr. Beast bars, by the way. They have not paid me yet. So just think about how many that does. And again, the ESL, DSL market is super interesting. There are tags now that if you're walking through the store and you're on your favorite retailer's app and you say, I'm trying to find the double stuffed Oreos, which I've never eaten, obviously, that you're not supposed to laugh at that. I mean, that hurts. And I say, find me the Oreos. If I'm in the aisle, at least I'm in the right aisle, which is a success for me, it'll blink. Hey, look for the blue flashing dot. So if that's what you're doing, that's great. Imagine you're an Instacart shopper or a shopper for your retailer. That's great tech. That's pretty awesome. But that's a lot of devices. So in order to handle these tens of thousands of devices, we're going to first talk about Bluetooth Low Energy, BLE. What does it take to use BLE in the enterprise? So this was something that I definitely did not know until I started going down the BLE path. BLE is not like Wi-Fi. If you buy your favorite vendor's access point, I think all of them come with Bluetooth radios, one or two or probably more now. They come with that. How many of you have ever used your BLE radio on your vendor's access point? Not very many. There's a reason for that. It's kind of a pain in the ass. It's not easy. And it's not the vendor, it's actually nobody's fault. There's no the vendors are not failing you. It's because BLE as a standard is not designed to handle multiple connections. Mark gave me a great analogy. He's like, when you put in your AirPods, it is pairing to your phone. Pair, meaning two. Just naturally doesn't do that, right? If you want to pair multiple devices together, something starts breaking. So the BLE radio on your, again, your vendor access point is super functional, but not out of the box. So what you need to do is, let's say your ESL provider and your vendor, you've got to put them together and say, you guys need to talk and make this work. So your Wi-Fi vendor will program it for your BLE vendor, your tags or locationing or the blinky lights, whatever it may be. You are asking them to make this work. And that's what has to be done today. The other problem is, what if you're a retailer that needs to use multiple BLE services? It's not just your ESL tags and maybe another technology. Now it gets even more complicated. So a company that I ran into is a company called Rato. Rato is a company that does a lot of different things related to Bluetooth and HaLow, et cetera. But one of the things they have is what I call a software abstraction. You install it, or your Wi-Fi vendor installs it on the AP, and now when you want to add a service, all choked up. When you add a service, you're going to now go to Rato and say, hey, can you program for my 3 new vendors I'm going to use BLE for? And then they make that happen. If they don't already have the link, which they likely do, then they build that link for you. So they're like an abstraction software to make that happen. Now, there are cases that's happening again already where if you have a properly designed Wi-Fi network does not equal a properly designed BLE network. Those are not the same thing. So you may have to add BLE gateways. Again, Rato does that. So there's more and more services heading that direction. Another service, or another technology, I should say, that is for high numbers of devices is called HaLow. 82.11ah. For those of you that it's probably new to many people, it was to me, operates in about typically 900 megahertz. When I was first starting Wi-Fi, which is in the 2001 range, a lot of us talked about using 900 megahertz because it's great range. So it's this lower frequency, which is good, but you're gonna see that that isn't its greatest advantage. It has really good security, we need that. Its data rates are decent. How much data do you think it takes for these digital shelf labels or to have a blue light come on for your double stuffed Oreos? It's not a lot, right? We don't need to move massive amounts of data. We just need it to work for a lot of devices. So there's two main factors. One is low power consumption. We need this to last for years. If you're a retailer, and let's say you have 1,000 stores in your retailer, and every 6 months you're changing out batteries on your tags. That's not good. That doesn't work. That's not scalable. So you need them to last for years. HaLow as a technology allows that or has the ability to have very low power. And then the second one is high device density. I think I asked how many can an AP, can a HaLow AP handle? And it's over 8,000 by standard. I don't know if it's been tested to that yet, but thousands have been tested. So HaLow is a really cool up and coming technology that is worth looking at. Depending on your environment or depending on what you do, it's something to just keep your eye on. So now we've got all these technologies that we, what? Okay, that's some hella service, man. I appreciate that. Mark Edwards, everybody, appreciate it. So right from the fields, hitting 7, 8, 9 wireless technologies and vendors, that has been the journey of our humble tomato. Thank you.